In this diagram, a lot is going on because I wanted to describe the overlap between key tools for both functional and performance testing, supporting unit to integration stages of development. Let me first highlight the different types of automated testing. I'll be revealing each line and box at a time, starting from apps running in a system under test, accessed by an application client, which today is typically an internet browser such as Google Chrome running on a laptop. There are several different types of testing throughout the development lifecycle. One aspect is to see whether the user interface, UI, displays what users are intended to see. This is typically called functional testing. What users see on browsers today are changed by JavaScript, which manipulate what is in each user's browser domain object model, or DOM. Another type of testing targets unit testing of REST APIs, or application programming interfaces, which computers use to talk with each other without human interaction, usually transferring JSON formatted files. Functional integration tests see how various services interact with each other. Then there is load testing, which imposes an artificial load to surface issues. It's done to identify whether the infrastructure can indeed deliver acceptable response time, absorb spikes, scale well, not leak memory, and meet other what are called non-functional requirements. Tools for both categories are here in one diagram because job descriptions now are asking for skills that used to be in previously segregated jobs. Load testers must now know functional tools. Site reliability engineers who used to just monitor things now must also know how to insert synthetic loads. Developers are expected to know everything. That's the new strategy for small, agile teams. So let's dive in a little bit deeper. Development teams code JavaScript, even while offline, to use Google's Angular, React from Facebook, Vue, or other library. Google created Jasmine to test code using Angular. Jasmine had a batteries included approach, so Mocha came along with a focus on assertions and depended on other libraries such as Chai to innovate on mocking, snapshotting, and other features. Then Jest was created along with React by Facebook with the same one library does it all strategy, but with even more features than Jasmine. These are unit testing tools. Built into the Chrome browser are Google's developer tools, which are used to manually identify the identifiers used to automate the clicking and typing in the UI. Selenium scripts reference those identifiers through a WebDriver program which controls each browser. Each WebDriver exposes an API that automated testing scripts call. This design is why functional test scripts can be written in any language, Java, Python, C#, etc. Selenium provides a framework for organizing the scripts. Protractor adds to Selenium the ability to interpret the Gherkin written language to specify tests in a more natural way. Protractor also has a better way to dynamically read the DOM, which stores the state of each user's browser, which Angular, React, Vue, or other UI libraries manipulate via JavaScript. To unit test API services exposed by an app, developers often use Postman or SoapUI because they're free open source tools. By the way, SoapUI also tests REST APIs exchanging JSON formatted data as well as SoapXML. Karate, Rest Assured, and Pact are often called integration testing tools because they're used to catch errors and dependencies among services needing each other. Those who seek to shift-left testing for performance make use of Google's Lighthouse audits to get recommendations about techniques to speed up browser display, right in the Chrome browser under Developer Tools. Google Analytics provides timings for web traffic and public production. In the current movement towards reusing functional test scripts for use in performance testing, one approach is to modify functional test scripts to obtain timings on each step within the app and store them in a time series database so that alerts can be issued when anomalies are detected. But the principal approach for performance engineering is to create an artificial load on apps using load generators operated by load testing scripts, that replace manual work on real clients with synthetic or virtual users. The number of virtual users is often used to define the level of load imposed by scripts. While load is being injected, status such as the rate of transactions and errors encountered are reported by load generators to some master controller. Metrics such as CPU and memory utilization within servers are obtained by Dynatrace or other monitoring agents installed on servers. Results from runs are then analyzed and presented in dashboards. Traditionally, to get load generators to run as many virtual users as possible, load testing scripts don't duplicate what occurs in the browser, but mimic just what is exchanged over the network wire between an app and its clients. Communications are captured as load test script lines, then edited to add correlations and verifications. That's what LoadRunner's VuGen, JMeter, and other proxy-based client emulators do. Then innovations such as HTTP2 asynchronous communication and AngularJS code running within browsers cause more and more processing within browsers to occur instead of on servers. So TrueClient for the LoadRunner was created to record and emulate the DOM and actions of each individual virtual user, such as clicking buttons and typing on forms. JMeter scripts can also make calls to WebDriver APIs like Selenium. Taking an alternative approach, Neoload can call Selenium scripts as well as scripts created the traditional way. The newest innovation is Flood.io's element, which instead of calling WebDriver APIs like Selenium, calls the newer DevTools API protocol using the Chrome Puppeteer headless browser control technology, both from Google. Their element scripts can be converted from Tosca functional test scripts, which uses a low-code approach. That's why they are the new darling among those who test SAP and Salesforce. This keeping track of each user's browser memory can take up a lot of RAM. So cloud-based services make sense to use a lot of load generators for a short time, making cloud more affordable than having to buy a bunch of on-premise servers. Cloud services include StormRunner, BlazeMeter, Flood.io, and others. To load test APIs, tools such as LoadUI automatically convert SoapUI unit testing scripts into load testing scripts. SoapUI and pack files have the advantage of containing data values specified during recordings. OpenAPI Swagger specs do not contain data values, but variation in a large number of values are needed for any long-running tests anyway. To achieve shift left, our objective is to begin load testing as soon as code is pushed or merged from a local Git repository to a GitHub or other version control repository. Part of the modern development toolchain are static code scanners and dynamic code profilers to detect issues while the code is still fresh in the developer's mind. This also applies to security-type testing. Hooks in the repository can automatically initiate build of app instances, monitoring, profiling, and other preparations before kicking off a load testing job. When a cascade of automation can step through several test environments if all tests are successful, changes can happen safely yet quickly, so quickly that they're called continuous integration and delivery, or CI/CD.